Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this problem without any help. So let's go over it and let me show you how I did it. Okay, so question 3015 is count the number of houses at a certain distance 1. Okay, so basically you're given three positive integers and you have houses from 1 to n inclusive. And basically you're going to have a house going from I to I plus 1 and I plus 1 to I. So you can see here that it says they're undirected. It should say undirected. There's a street connecting these. So connecting implies that they're undirected. And so basically what you want to do is for each time from 1 to 3, count how many pairs of houses that where the shortest path of that house is exactly k. And k is from 1 to 3 in this case, or from 1 to 5 in this case. Okay, cool. So let's go ahead and build a graph. And let's make this a set. And basically, let's just go ahead and do exactly what's asked. We're going to add y because this is undirected, and y.add x. Cool. And then for I in range from 1 to n plus 1, because we want n inclusive, we're going to go ahead and add I plus 1 and d of I plus 1 dot add I. And cool. So only I to I plus 1. Okay. And so it actually says n minus 1 here, so we're actually going to do this. Cool. So now, basically, we're trying to find the shortest path of every single pair between 1 and n. So you have 1 and 2, 1 and 3, 2 and 3, and then, yeah, 2 and 1 has already been calculated. So that probably gives us a hint what we want to do, and we want to record at each time. So basically, let's just go ahead and get all the pairs, right? So from 1 to n plus 1, I plus 1 to n plus 1. And let's go ahead and calculate the shortest distance that we can find, right? So let's call this 1 and 2 is I and j. And then let's make a q. And basically we're going to have 1 in there. And we're going to run a BFS, basically a Dijkstra's, to find shortest path between these two nodes. So let's actually put the time and the actual node. The time is going to start at 0 because we want the shortest path, which is the shortest time. And then basically we're going to get the time and the node, and we're going to heap pop from the queue to sort by the time and then the node. Cool. Let's create a set called scene so we don't have an infinite loop. If node is in scene, then we continue. Otherwise, we add it. And we explore the node's neighbors, which are the connected elements. So for neighbor in D of node. So now we want to heap push onto the queue, time plus 1, and the neighbor. Cool. So at any point, if the node is equal to 2, then we've reached our destination, so we can print the time. And that will probably give us the best result that we want. In this case, for example, 1 and 1 and 1. So basically, let's go ahead and print the nodes and the time, and then let's break it as well, because Dijkstra's finds the very best one. So at time 1, we have 6 pairs because 1 to 2 and 2 to 1, so 2 of each, right? And then you see there's no time shortest path from any pair that takes time 2 and time 3. So basically what we can call this is, let's call this calculation, and default dict of type set, because we're going to basically use the time to add 1 and 2, and also 2 and 1, right? 2 pairs for each. So each pair has 2 combinations. Okay, cool. So now we can loop from 1 to n plus 1. And again, we're just going to see how many pairs for that particular time, right? So we're going to append calc of I, and we're going to take the length of that, which is 6 in this case, for the first one, and 0 and 0, right? And then at the end, we can just return the answer. So let's run this. Okay, it doesn't look correct. Let's go ahead and print calc. Oh, we forgot to add, there's a typo there, right? Okay, cool. So you can see 6, there's no 2 and 3, there's no time. In this case, there would be no time 4. So there's no key of 4. That's the key is the time. So, yep, let's submit this. Okay, and there you go. Passes all test cases. So again, I'm super happy that I was able to solve this question completely on my own without any help. So, yep, that's it for this video, and that's question 3015.